name and your profession.
My name is Milo IV, or Dr. Milo IV, and I am a research fellow at Curtin University in the discipline of Earth and Planetary Sciences.
Fabulous. All right. I'm going to pronounce this incorrectly, but what are cenotes?
So cenote are basically one of the words we have for sinkholes. They're particular for on the Yucatan Peninsula in Mexico, where they have particular cultural significance there related to the Mayan people, with interest of the Yucatan Peninsula. Oh, yeah.
Sorry.
I can start again because that was rubbish.
Good warm up.
Yeah.
Do you want me to start from the very top about my name? Because that kind of seemed like a fumble, or is that all right?
Oh, no, that's fine. That's fine.
It's not the most important thing.
Well, no, because we'll probably introduce you in voiceover anyway.
Okay.
So, yeah.
But good to get
But
it
it's good to have it on camera and your pronunciation and all that kind of stuff. It's just a popular little area, isn't it? All right, let's give it another go.
So cenote are a karst feature that are well known from the Yucatan Peninsula in Mexico and the Gulf of Mexico. Basically, they are collapsed features into these underground passageways, and the distinctive features of them are that they are open to the atmosphere. They go down into these caverns into the limestone bedrock, and they are water filled. There's lots of different names for these around the world, such as sinkholes or swallow holes or dolines in Australia. So they sorry guys.
No, I was scared. It was a really good answer, so I was letting you go.
Yeah.
But she was chatting away, unfortunately. So we might do take 3 on that if that's okay.
Yeah, we've got a couple of people coming through. I don't think I've ever seen it this busy this time of day.
I know.
No, it was fine about 5 minutes ago. That's how we set up here.
I don't even.
So there doesn't seem to be anyone else coming. Maybe just a lecture just finished. Well, like something.
Open days or wanderings. Coming back from the TAV. Still barred, are you?
No, I was never barred.
How much detail do you want me to go into on the cenote here? Because I could probably start answering a whole lot of different questions.
You know what? You can answer, I think, as much as you like.
Yeah.
We can just cut. We can cut stuff. So, I mean, they're the questions.
Yeah, because I mean, I could go into the details of how they're created there, or do you want me to just keep it short and sweet? What are cenote?
Look,
You don't mind? We'll just flow with it?
Why don't we
Keep it short and simple?
It's going to be whatever's.
Same question twice anyway.
Yeah, I probably
Grand.
will.
Oh, that's fine. Okay.
So if it flows to go into it, perfect. And then you might get me going. Oh, so what is it?
Yeah.
And you might just answer that. But it's just so we can get in a different way anyway.
Yep. Okie dokie.
All right. Take 3.
Okay, so cenote are basically these open caverns basically formed in the limestone bedrock, where we have dissolution opening up of a cavern, and that collapses through, opens up to the atmosphere, and we have these cenote that are famous from Mexico and the Yucatan Peninsula. They are distinguished by the fact that they are water-filled, but we have similar terms for these same features worldwide, and so they're known by dolines or swallow holes or sinkholes, etc. worldwide. But the cenote term comes from the Mayan for basically a water deposit, which was obviously their main source of water. Because of it being a karst landscape, there's no surface water ponding in lakes or rivers going across the Yucatan, so all the fresh water was accessed via these collapse features that open to the atmosphere.
Okay, this is all news to me, to be honest. So how were they then created?
Might just wait so there's an aeroplane and some laughing.
No bother.
Hectic.
Just do it at night time when there's no flights allowed. In the dark.
In the dark, yeah.
With a misty spray going on.
We're in a sinkhole at the moment. I can just say that. Don't bother looking around. But yeah. So it was a sinkhole along the Nullarbor.
Yeah, they call them dolines there, dolines there. But yeah, essentially it's the same thing. Once you have these dissolution passages opening up to the sky, then they're all one and the same. And it's only because like I said, the name cenote means water deposit in Mayan.
Yeah.
That's why they're named there. And because it's so bloody touristic now.
Yeah.
That name is now being spread and applied elsewhere.
I see. Okay. How are they, specifically in Mexico, let's say, How was it created?
So the cenote on the Yucatan Peninsula were created as a result of the geological controls, basically. So we have that whole region was once submerged, so millions of years ago. That was under shallow tropical seas, and those shallow tropical seas are ideal environments for carbonate producing organisms. So things like the coral reefs that we're familiar with, they produce calcium carbonate skeletons. Those skeletons accumulate and other different calcium carbonates precipitate in the water, and it accumulates into these thick sequences of limestone. Subsequently, during these lower intervals of sea level, that limestone is then exposed and it starts being dissolved away by different actions of things like...
Sorry.
That's all right.
Sorry.
These guys are just doing laps, I reckon.
Yeah. Us again.
No, here. It's always the way. As soon as you bring out a camera,
Yeah, we should set up some decoy ones. Just to lead them astray. Yeah.
I reckon if we go from maybe periods of, well, I mean wherever you want to, but I think the noise kind of cutting when you're talking about periods of low sea levels, possibly.
Okay,
But
let's
start wherever.
okay, so the...
Hang on.
Oh, sorry.
Sorry.
That's all right.
It's going to cut.
Okay.
Small world.
There you go. So what are they? How are they created?
Yeah, how are they created?
Okay, so cenote are formed in regions of calcium carbonate limestone, basically. So they're karst features. So the limestone on the Yucatan Peninsula in Mexico was formed when that region was submerged in a shallow tropical sea. So millions of years ago, tens of millions of years ago, we had these shallow tropical seas, which were very nice places to live for these creatures that produce calcium carbonate skeletons. So things like tropical reefs that we're familiar with today, and the warm waters enhancing the precipitation of this limestone built up these kilometers of limestone essentially during periods of high sea level, when that region was flooded. And when sea level fell away again, that limestone was exposed to the atmosphere and it started becoming dissolved. That dissolution can occur due to rainwater interacting with carbon dioxide in the atmosphere, or percolating through the soils and taking CO2 from the soils there and produces a weak acid, carbonic acid. Also there's bacteria and microbia, I suppose, that produce sulfur-producing organisms that make sulfuric acid during the degradation of organic matter, and that also can start dissolving away the limestone. And finally, where we have this interaction between fresh water and salt water, like we have across the Yucatan, because it's so low-lying, we have a very thin lens of fresh water sitting on top of the salt water, and at that interface we have the dissolved salts varying to such an extent that we preferentially dissolve the limestone bedrock as well. So even though the limestone sequence is mechanically quite strong, it's chemically susceptible to this dissolution process. So anywhere where we have focusing of that dissolution process in a low where water gathers, or along fracture planes, or some means of confining the water flow with impermeable layers, we're going to have enhanced dissolution processes that creates these caverns that are water filled. Then maybe during the last glaciation, when that sea level dropped maybe 120 meters, those caverns became completely air filled. That loss of support would enhance the collapse of the ceilings, and the collapse of the ceilings essentially opened up these caverns to the atmosphere, and we have an open chamber now. When sea level subsequently rose again, and the ice sheets melted, we saw the water table coming back up, rebounding. The groundwater now fills these karst systems, and we have the cenote that we see today.
Excellent, thank you so much. Just out of interest, what kind of quality is the water like in these kind of things from your experience?
So the water quality can vary massively depending on, I suppose, what what's occurring in the region. How thick the soils are is a particular consideration. How much agriculture, how much kind of industrialization or urbanization is going on. The problem with these areas, especially with these karst systems, is that through most of the rock there's not much water flow, but in these very defined conduits we have enhanced water flow. So any pollutant or surface contaminant that goes in typically then gets into the subsurface, into the cenote system, these underground cave systems, very rapidly, and it spreads very rapidly as a consequence. There's not much filtering processes and things that will capture and clean up the water before it makes it into the underground system, so they are liable and easily contaminated.
Pause there for a wee moment.
Sorry, I know that was a bit of...
That was it. That was handy, just being able to drink from the water. I wouldn't do it. Although we did check if there were any, dead muskox upstream. I suppose it's the only thing you got to worry about.
Nothing to contaminate it.
Yeah.
Cool, I think that'll...
Do you want me to add a bit about that water being typically of high quality and the clarity being pretty high?
Yeah, that would be great if,
Yeah.
if you've got a little line that you'd like to throw my way. So yeah, tell me about kind of what kind of water you'd find at the bottom of these things.
So the water quality in general, though, obviously we've seen it from the tourist brochures, the water is typically very, very clear, and obviously was suitable for drinking by the indigenous peoples and mines used to use it as their primary freshwater source. What is interesting in a lot of these cenote is that we actually have the boundary between the freshwater lens and saltwater sitting beneath it. So we have this halocline, as it's called, this basically change in salinities. So you can descend through very clear fresh water with lots of light penetration, but at that boundary we have a difference in densities and refraction and a little shimmery effect that often people are quite startled by. Or certain horizons within the water column where hydrogen sulfide is accumulating and it gets very, very cloudy. And this can be quite frightening for people. I think the famous cave for Angelita, where you actually descend through this murky cloud, which you can actually smell as kind of smell of rotting eggs, or in some places they're so kind of strong, the hydrogen sulfide, that it can cause irritation of the skin. Once you get there down to the very bottom, and part of the problem I suppose is where there have been accidents in these situations before is the very, very fine sediment that settles on the bottom. Once that's stirred up, can cause a lot of turbidity, and that can take a long time to settle due to the fine nature of the sediment. So once it's turbid, they can take a long time to clear, and people become disorientated in these systems, and hence can I suppose we have fatalities recorded as a consequence of that, where sunlight's blocked off, they don't know where they're going anymore, and they panic.
Yeah.
Oh yeah, I forget about the old planes.
And truck, so good timing. At least it's all
At least
happening at the
they're
same time.
combining their trips now. Yeah.
I wouldn't mind cruising around all day in one of those little trucks. Just for the novelty of it all. That's true.
We've got a little.
All good for the moment. There's a couple of people coming.
They look like they're chatting.
Do you want
So
to
it wasn't
stall?
designed by any of the students or staff
No,
here?
don't
No.
think so.
Oh, okay.
They got.
Pretty good. Yep.
Alright.
One more thing I was going to say about that was part of the reason I suppose that there is such exceptional water quality and clarity there is that the water flow rates are very, very slow. So because of the very, very low topographic relief across the Yucatan, you're looking at an average maybe 10 meters, and the water lens being very, very thin on top of the salt water, you don't have much of a height differential in the fresh water, so you're not generating large flows. So typically things are very, very still, and that allows all the particles to settle out, enhancing the water quality as well.
Fabulous. Thank you for that. Okay. How long ago, is it possible to estimate roughly how long ago the process of them forming or collapsing would have happened?
Yeah, so trying to put ages on the formation of the cenote, I suppose you need to understand the timings of the sea level fluctuations, which are driving that fluctuating groundwater table and interaction with the acids that were creating them, also the collapsing of the ceilings. But one way you can do that is looking at the cave deposits that are inside them, the speleothems. And these are things like the stalactites, stalagmites, curtains, flowstones, etc. And you can actually date those structures specifically using the way that uranium gets incorporated, or the way that these radioactive elements get incorporated into the stalactite itself. And through the process of radioactive decay, we can measure the daughter and parent isotope ratios to get an absolute age on the structures themselves. Another thing that we can can look at is we often find fossils within these caves. So these fossils, particularly if they're sufficiently young enough, say in the last 50, 60,000 years, we can apply things like radiocarbon dating. And beyond that, we have to use other techniques essentially. So we will see that there was definitely these open systems, at least in the last interglacial, when 125,000 years ago, when sea levels were much lower, and creatures were going into the system then. We do have caves as well that are millions of years old, and absolutely constraining ages on things that are continuously changing, and I suppose being eroded and connected in different ways is challenging.
And so I guess on that, are they still growing, shifting, changing? Or?
So yeah, the cenote and any karst regions are particularly dynamic. I should say particularly dynamic on geological timescales. What you will find is there is constant dissolution going on, and particularly looking at levels where the groundwater, or where the freshwater saltwater interaction or that interface is. Divers will note about maybe enhanced width of the cavern at that level or something. So you can see that processes are ongoing. In terms of collapses and things like that, these are natural structures, obviously quite steep-sided in places, and there is a lot of evidence for rubble and things like that within the cenote, but active collapsing is one of the lowest probably concerns for people in terms of any sort of a danger within these. The biggest concern maybe would be where most human traffic or buildings are going on near the lip or edges of these structures. You might see enhanced collapsing then, but in terms of internally, the natural kind of processes of driving stabilized arches, shapes within them typically means they're quite robust. But yeah, the processes of dissolution are constantly ongoing.
Do you have any idea about roughly how big some of these are at this point in time?
So there's I think recently there's been a discovery that of two once considered separate cave systems have actually now been found to be connected, and we have a connection total length of over 347 kilometers, I think, of continuous cave passageway that is not necessarily navigable, but connected through as a single water system. And you can start using dyes or some sort of chemical compound to trace water through these systems where it's too challenging for divers or any sort of remotely operated vehicle to get through. Because obviously 350 kilometers is quite a way to go. In terms of depth, I think...
I might just have
I usually try and find a nice part of your sentence to politely tell you to stop.
I should probably be paying more attention.
No, don't. That's our job. 100% our job. Since neither of us are willing to stop here. Apologies. Wherever you want to start from, but I'm sure we're good up to...
so the length connection?
The length connection.
So go to the depth now, it'll be fine.
Yeah.
So in terms of depth, we see typically they're in kind of maybe tens of meters of depth, and that is likely being controlled by the actual position of the elevation of the land surface and the depth of groundwater. We see some structures getting down to maybe 120 meters beneath sea level, in particularly deep examples, and there is a structure not in the Yucatan Peninsula, El Zacatón, I think in central Mexico on the coast there, that's actually over 300 meters deep. And they are associating these deeper, more cylindrical structures with water actually coming up from underneath and percolating upwards, with the aggressiveness actually driving the growth of the cave upwards from that. So in the case of El Zacatón, I think it is being postulated that it's volcanic activity producing these acidic groundwaters that migrate upwards to create the significant depth.
Okay, amazing. So the majority of them are formed by, I assume, rainwater pooling on the top,
and working its way through this.
But some of them are from the bottom.
Upwards, yeah. I could give you the term if you want, hypogenic, but I'm not sure if that's going to be of relevance to people.
Yeah,
or
no,
not.
give it. I mean,
Yeah.
absolutely. So the term is what? Sorry?
Hypogenic.
Okay, and what does that refer to?
So the term hypogenic basically refers to this growth of the caste system conduit going upwards. So instead of it being a top-down kind of generation, it's a bottom-up generation, and so it's the deeper waters that are driving the dissolution process. So it could be deeper source of sulfur that's driving the sulfuric acid, or it could be carbon dioxide or sulfuric acid being given off by volcanic systems, or something interaction with the deeper waters that's been, particularly if there's heat involved, driving these warmer waters coming upwards and creating the dissolution, when you typically get these kind of chimney-like, more chimney-like structures, and deeper and contained.
Great, thank you.
Airplane.
Sorry, are you going all right there? Getting a bit warm. I can see the sun creeping towards you.
It's creeping.
Nah, I'll be alright. I'm Irish, so we're well used to heat.
Yeah, absolutely. Your skin will just bounce,
Actually,
reflect the sun perfectly.
Tough as nails, boy.
All right, we'll keep it quick.
No, I'm honestly, I'm grand, so whatever you need to do.
Okay. Thank you so much, Milo. We appreciate it. Why, in particular, are there so many in this area in Mexico? What's happening with the landscape there to make them?
Okay, so the significance, I suppose, of cenote in the Yucatan Peninsula and why they're so well known from this region is partly because of the cultural significance of them related to the Mayan people, partly because it's in quite a nice tropical area that people like to go to, but mostly it's to do with the geological controls underlying it. So the reason that we have these this nice, homogeneous, thick layers of limestone that are mechanically strong but easily dissolved across the region. It's all very flat lying. It hasn't been deformed or tilted up, so these systems can become quite extensive. We have a wet season that's giving us, I suppose, enough sufficient moisture to drive the dissolution as well. But fundamentally, we'll see the concentrations in two kind of main regions in the Yucatan Peninsula. We have an eastern kind of belt, but we also have quite a conspicuous kind of ring-shaped structure of the cenote that has been subsequently correlated with the Chicxulub impact crater. So we have the impact crater that is responsible for the mass extinction of the dinosaurs. This has caused, or thought to have caused, fracture patterns in basement, things like that, and we get enhanced flow of groundwaters. Concentrate. That's right.
Please, guys. Sorry to interrupt. It's just reading out.
It's a good microphone we've got.
Normally it's not too bad if it's around there, which is... Sorry.
That's right. So the main thing are the geological controls on the cenote formation in the Yucatan being perfect. So we had this period where we had the extensive carbonates being deposited across the region. They developed quite thick sequences. The limestone itself is nice and pure. It's not been deformed or folded in any way, so it's nice and horizontal. It's maintained its position relatively close to sea level, where the groundwater saltwater interaction can occur. We have these wet seasons that drive the fluids down, that enable the dissolution from the surface. But we also have geological controls in terms of a distinct ring-like arrangement of an...
Sorry, Milo. sorry.
It's not our day today.
Sure.
I don't remember the flight path being directly over curtains, but obviously it is today.
You never hear it in the pub, though.
Well, yeah, I was mostly an art student. That's where I spent most of my time.
So if you just go from this ring structure, I'm sure you'll be fine.
So a conspicuous feature of the cenote in the Yucatan Peninsula is the arrangement of a ring, concentration of cenote in this ring that is associated with the Chicxulub impact crater. So about 65 million years ago, we had this 12-kilometer wide impactor from outer space hitting in the Gulf of Mexico, created obviously a rather large crater, over 180 kilometers or so, and worldwide devastation associated with the extinction of the dinosaurs. Associated with that impact structure, we obviously generated a lot of fracture patterns that enhance fluid flow, and we modified the subsequent deposition of sediments as well in association with this crater. So at this margin of this ring, we are enhancing the fluid flow, which is creating enhanced dissolution and greater concentrations of cenote.
Fabulous, thank you. I love that it comes from the extinction of the dinosaurs.
It all comes back together in the end.
Yeah. Okay. So I believe they exist elsewhere in the world. Are you able to tell me where else they can be found?
Yeah, so cenote is again, it's a term particular to the Yucatan Peninsula in Mexico. So in other parts of the world, we have very similar features. These water-filled collapses, and they might go by other names. So you might have heard the term swallowhole or sinkhole, or doline in Australia. So you'll find them worldwide, anywhere where there's limestone essentially accumulated. So any of these limestone, broad expanse regions of limestone, you'll never find these, or you rarely find surface rivers and lakes, because most of the flow is occurring in subterranean. And so the dissolution is occurring subterranean. If you then open that system up to the atmosphere and it's maintained filled with water, then you might call it a cenote. And that term is getting more globally recognized and utilized because of the increased tourism flux to Mexico, taking that term elsewhere. But essentially they are found worldwide where the groundwater is sufficiently close to the surface to fill these structures up. Elsewhere you might find that because of the nature of the karst system, these might be temporarily filled. So during very wet seasons, you'll see the groundwater table coming up and it'll be filled with water. During the dry season, it might drain away completely into the karst system.
Great, thank you. Got through that one. Yep. Well done.
Is that a plane coming?
It is.
It is.
Definitely is.
It's not too. Oh yeah, no.
Nah.
It will teach us.
I've only got a couple more questions.
That's all right. I'm trying to think of. I think there's a whole lot of names that I should have filled in of certain sites, but I'm sure that you'd be able to get there.
If you know of any, feel free to list them. If not, we can do it in voiceover, so it's not a problem.
Wait, is there anything that's particularly unique about this site in Mexico?
I suppose it being. Is there anything particularly unique? I mean, if you go out to the nullarbor, there's a shitload of holes. It's just that the water table's so low there that they're not, and there's fuck all people out there. This isn't recording, is it?
Well, it is, but we won't use it. PG friendly.
That no one really goes out there to see them. But I mean, there are some sites that are closer to the coast in South Australia that people would go to, and swim in similarly. But because I think it's just the picturesqueness of the tropical rainforest and these systems that makes it,
There's the one that's near Cocklebiddie, the Cocklebiddie Caves. That system. There's like some guys who I think are a bit mad, but they're going to go down, swim. It's about 5 kilometres underground and it's relatively flat. And they want to shoot it in 3D. They've done it like 10 years ago, and there's a section where they have to take off all their breathing apparatus.
Fuck that. I've seen them pushing stuff ahead of them, squeezing through stuff.
And then hold their breath, and then pull it all through and put all their devices back on.
I can't think of anything more hideous, to be honest.
And it's pitch black, so all the light that they take is their own. If anything goes wrong, then they're done for.
Because we had this crazy Polish guy come over who used to do these like extreme deepest cave dives in the world and stuff, and then he, unfortunately, he died